In the previous episodes, we defined the boundary and understood the context. Now we take the next step. We follow one environmental topic, water, across that boundary, because this is where the system becomes tangible. Scope defines what is included. Context helps us understand what matters. But at some point, we need to translate that into something concrete. And that is what we do here. So we take one topic, water, and we follow it across the system. When the standard refers to a life cycle perspective, it does not ask for a full life cycle assessment. It asks for something simpler and more useful, to think beyond the physical boundary of the site, not for completeness, but to support decisions. And to make this practical, we use a simple structure. Upstream, what comes into the organization. On-site, what happens within the organization. Downstream, what leaves the organization. And the external providers, so activities connected to us but not performed by us. And this gives us a disciplined way to think. So this is the map we will build. At the moment, it is empty. By the end of this exercise, we will have populated it with water-related activities. And that will give us a life cycle view of water. Okay? So, we start upstream. Even before water enters the site, it's already part of the system. So, ingredients depend on water. Packaging, whether plastic, glass, or paper, also involves water use. And suppliers themselves may operate under different water conditions. So, water is already embedded in what the organization buys. Then we move on-site. So, this is where water becomes visible. Water intake, storage, use in mixing, cleaning cycles, often one of the largest uses, then cooling, sanitation. So this is where most organizations focus, but it's not the whole story. Next, downstream. So water leaves the system as wastewater, as sludge, through transport-related activities, and sometimes through product use, depending on how the product behaves. So this is where impacts often become visible externally. And then we have external providers. So activities not performed directly by the organization, but still connected to it. So things like warehouse cleaning, transport washing, contractor activities. So these are often outside the traditional boundary, but not outside the system, especially where the organization can control or influence them. So now we put everything together, and what we see is that water flows across the entire life cycle, from suppliers through operations to downstream and external activities. So this is the real system we are managing. And when we see the system like this, something changes. So we move from isolated processes to a connected system. So decisions in one part affect others. Risks and opportunities become more visible, and priorities become clearer. The organization may not control all these activities, but it may influence them through specifications, through supplier selection, through contracts, through communication, and that is enough to bring them into the thinking of the EMS. The purpose of this map is not to describe everything. It is to support decisions. Where is water most critical? Where are the risks? Where are the opportunities? So the life cycle map helps us focus. If you only see water inside your processes, you are only seeing part of the system. Realistically, let's see. For BlueRiver, the most significant water-related environmental aspects will probably be concentrated on-site and downstream, with some important influence points upstream and with external providers. So let's see upstream, yes, but mostly through influence, okay? So likely significant aspects will have something like supplier water dependency for ingredients, so especially if BlueRiver uses agricultural ingredients, fruit concentrates, sugars, syrups, or flavorings from water-stressed regions. Water use in packaging production, so relevant for glass, plastic bottles, cartons, labels, and cardboard. So BlueRiver may not control these directly, but it can influence supplier selection, specifications, recycled content, and sourcing criteria. Then let's focus on on-site. So on-site is probably the strongest area. So likely significant aspects, we have water abstraction, consumption, so water used for production, cleaning, sanitation, cooling, and utilities. So the cleaning and water use, often one of the biggest water users in beverage plants. So is the use of cleaning chemicals leading to contaminated wastewater. And this links water consumption with wastewater quality. So leaks, losses, overflows, poor rinsing practices. So these can become significant because they increase water use and wastewater volume. Now, downstream. Yes, especially wastewater, I think. So likely significant aspects, we have wastewater discharge. So probably one of the most significant aspects, especially if local receiving waters are sensitive or discharge limits are tight. So think about organic load and variability in wastewater. So carbon oxygen demand or biochemical oxygen demand, pH, temperature, cleaning residues, sugars, syrups, suspended solids, sludge from wastewater pretreatment, perhaps, so handling, storage, transport, and disposal, recovery of sludge, maybe, although it's not in the slide. Now, external providers, yes, where stormwater or washing is involved. So likely significant aspects, we have warehouse cleaning water and wastewater, especially if outsourced warehouses store damaged and leaking products, for example. Transport washing, so water use and contaminated water from cleaning vehicles, tanks, or trailers. Contractor activities, contaminating stormwater, for example, very relevant if stormwater drains discharge into the environment. So my judgment would be something like the most significant for BlueRiver would probably be on-site water abstraction and consumption, cleaning water and chemical use, wastewater discharge quality and volume, stormwater contamination from contractor or yard activities, and supply water dependency for key ingredients and packaging. Yeah, so the big picture. This is the bridge to the next step, environmental aspects. The life cycle view shows us where interactions with the environment occur And that is exactly what we need to determine environmental aspects in a meaningful way. So, what the life cycle map shows us is where interactions with environment occur. And that is exactly what environmental aspects are. For example, water intake becomes an aspect because it is the abstraction of a natural resource. Wastewater discharge becomes an aspect because it is a release to the environment. And cleaning processes become aspect because they combine water use with the generation of contaminated effluent. And even contractor activities become aspects where the organization can influence how water is used and managed. So, this is the key point. The life cycle view is not an academic exercise. It is what allows us to determine environmental aspects in a structured and meaningful way. A life cycle perspective is not about analyzing everything. It is about looking beyond the fence with purpose, not for completeness, but for better decisions. Now, in the next episode, we'll take this map and move to the determination of environmental aspects.